Welcome, everyone, to this week's episode of The Context. I am Shannon Williams. Super excited to be with you today with my co-founder here at Obot, Darren Shepard. We have an awesome guest speaker today. Brendan is joining us from Kilo Code, and we'll give him a proper introduction in just a minute. But just wanted to get everyone excited. It's been a fun month in MCP land and for the AIF. If everyone's been paying attention, we are coming up in the next, this month, we're going to be having the next big release of the protocol. We're starting to work on bringing together a group of speakers and some people to chat about that in the next few weeks. I don't know about all of you, but I've been in and out of a couple vacations or work travel off to India. So it feels like everything kind of moves faster all of a sudden, jumping away. And then you come back and it's like, oh, we're 2 weeks from that release and this is going to be coming next. The travel is not set to stop for me. I am getting ready to head out in September to the Shanghai and Tokyo events and Amsterdam events. So we're going to be on the road a lot. I'm not going to Seoul. Darren, are you going to go to Amsterdam? Have you booked flights yet? I don't know.
I have not booked anything, so I don't know.
I think you should come to Amsterdam. Amsterdam's going to be fantastic. It's the scale of Amsterdam is always I think it's going to be the biggest one we've done yet anywhere in the world, and it'll really be the first one that is under this like Agent Con, MCP Con moniker that the AIF is using now. But it should be a really interesting event. The number of speaking submissions is overwhelming. Both that and San Jose are kind of crazy. I just was going through and reviewing sessions for Tokyo, and there are tons of great talks. So I think we'll be announcing the Shanghai and Tokyo sessions in the next couple of weeks. So if you haven't gotten tickets yet, my goodness, get them. If you live in Korea or China or really anywhere in Asia, we're going to be there. So come on out. Either I think Angie will be in Seoul, I'll be in Shanghai and Tokyo, but we will have an excellent presence all over Europe and all over Asia and Europe in the early fall before heading back to North America in October. So the speaking talks may still be open for Toronto. So I know San Jose just closed, and again, over 1,000 submissions of talks. So it should be an incredible set of speakers. But Toronto and then the event in Nairobi, which I'm really optimistic we'll see some great talks and interesting attendance for. And here at the Context, we have been kind of on and off a little bit the last week or so, the last couple of weeks. I think we did one 2 weeks ago or so before I left on vacation and Darren left on vacation. But we are back for a few good weeks. I know we've got all of this month. We've got talks coming up every week. And I think August is going to be quite busy as well. So excited to get you some great content, and definitely we'll have at least one talk really diving into the new spec, the new release that's coming up later this month. So with that, let's get things turned over to Brendan. Brendan is the head of developer relations at Kilo Code. He is here to talk to us today about all of what they've learned. If you're not familiar with Kilo Code, they are an open source coding assistant that has gained a ton of traction and has become quite popular. And Brendan, welcome to the Context. Excited to have you here today.
Yeah, thanks, Chance. Thanks so much for having me. Really, really excited to be here. We're excited about everything the foundation's doing, and was excited to get invited to come on and chat a little bit about how folks are using AI and agents and MCPs and all that stuff in the development world.
When I saw your title, 40 trillion tokens, it just sort of, it kind of hit me like a hammer. I was just like, are we literally going to be talking about quadrillions? Are we going to be talking about whatever the hell?
Yeah, we need bigger numbers.
I mean, the numbers just become almost ridiculous when you talk about these things. It's like, though, to be fair, we don't really talk about bytes very often anymore either, because it's just,
that's true.
We would be talking about such insane numbers. So maybe we'll be talking about megatrillions or mega tokens. We'll be like, oh, I use 4 megatokens or 500 kilotokens.
Yeah, it's a weird world where like suddenly, I never would have imagined, I don't know, 5 years ago that we'd be talking about tokens, and tokens is suddenly this like really important unit.
I mean, it's so funny because you always kind of mocked the idea of, well, how many lines of code have you written? But now if you apply that to these AI code assistants, the number is it's also just like terrifyingly massive. I mean, I personally I can't even imagine the amount of code that I have.
Oh yeah, I mean, it's funny you mentioned lines of code. It's very similar. Of like lines of code has always been this terrible metric.
Yeah,
but it's the only metric we kind of like can gauge things by, so we still keep using it. Or it's like tokens is going to be this terrible metric, but we're still going to use it to gauge. And then engineers are going to be like, no, the number of tokens doesn't matter. It's the quality of the tokens, you know.
Well, Brendan, let us get out of the way and turn the floor over to you. Excited for your talk.
Yeah. And to your point, I can get started, and I've got my slides ready to go here whenever you can swap over to those. But yeah, it's interesting because actually the title slide you'll see is about 25 trillion tokens. And we'll talk about that in a second because you heard Shannon say 40 trillion. But I think it'll show us that when these slides were made, originally, the numbers were a lot different, and they're just growing at speed. And like you said, I don't know if they're a great measure of quality, but I think they are at least a measurement of the scale of what we're seeing. And so there's kind of, our goal again at Kilo, we're an open source agentic coding platform, as Shannon mentioned. But my goal with this talk was to actually bring, because we're open source and you can see the kind of data that we collect, bring the results of that data to bear on, okay, how are people actually using agentic engineering in production, and what lessons could we learn from that if we're organizations that are trying to understand how do we adopt these things. And I just think that is maybe the better thing to learn, that rather than saying, hey, let's go spend as many tokens as we can. The better thing to learn might be, as we're spending all these tokens, how can we understand adoption as leaders in the space, and understand how we can make developers actually successful with it, and thus get the quality up to where we need it to be. And so there's kind of three things I want to talk about, and we'll kind of unpack real world data that we have for each of those as we go. So one's the trust ladder, how developers have to build trust with AI and LLMs and agents in order to kind of build up to that kind of higher level of abstraction, the ability to actually have, teams of agents working on things. You can't do that unless you build kind of from the ground up a foundation where trust is kind of built. Second, we're going to talk about failure points that folks have that either can have them overspending on tokens, or overspending, even worse, on the cost of tokens, and how we can figure out how to show those in data and then actually have fixes for our organizations. And then talking about how we can measure trust from both of those things. It's different for each level on this ladder that we're going to explore. But it's critical, I think, again, in making developers actually successful with AI rather than just using AI. And so again, the original title of the talk was about 25 trillion tokens processed, but as with lots of things in AI, it's been very fast growing. And so then I actually changed it to be this 40 trillion tokens by the time that we actually got here today to talk about it. Although I actually looked at the number this morning, it's 45 trillion now. So again, we're going to need a bigger boat or bigger numbers, depending on how you look at it, in order to be successful here in talking about it. And I think the one kind of caveat I'll talk about here is, of course, this all comes from the data that goes through the Kilo Code infrastructure, our Kilo Code gateway. So we have both Kilo Code, the harness, which is like in VS Code or in your CLI or in your JetBrains, as a JetBrains plugin. But you don't have to use our Kilo gateway, which is the inference provider where this data is coming from. You can bring your own key. You can bring your own inference provider. You can run it completely offline without us knowing about it. So because of that, the data probably will skew a little bit towards early adopters and not a median portrait of the market. But it at least has, an idea of, where can we learn? What can we learn from all of these requests that are coming through the Kilo gateway about how developers make choices about using AI? And then we'll also talk specifically about model selection and the analysis there about how we can look at both back-end routing, but also specifically model choice by developers and how that matters. Again, I think that maybe, again, is something that's going to skew towards early adopters, just because being an open source tool, you're going to have a lot of early adopters in the data set, but hopefully we can all learn some lessons that we can take back to whatever size organization we're working with. And I think most teams, I think it's hard to kind of keep this in perspective because, at Kilo, we're in this every day. Every new model comes out. We're on top of it. We know oftentimes we have access before the model's even released. Right now we're anticipating a big model drop any minute. And feels like almost every day is that way. But most folks are, much earlier on this kind of adoption path where they're coming from maybe more of a co-pilot style use of, autocomplete or chatting to actually having, agents that can action and take actions for the user, whether that's maybe the simple action of writing code or writing code files, or maybe more, in-depth things where AI can run more commands on the workstation or actually get involved in the deployment process, act in the real world, act in the environment as the user. And then once you're able to do that, I think you're going to get to this, okay, now I can, if I have the level of trust where I can do that, I get this ability to then orchestrate multiple agents. And if I can do that, then now I'm putting a lot of trust into the agents if I'm giving them kind of autonomy in order to act on my behalf or act in the infrastructure. And there's a couple other things about these rungs that we want to talk about here, right? We see here also the feedback loop. What's the feedback loop like? And I think that's a critical thing to think about as folks are adopting, is because the feedback loop on autocomplete is I'm right there, I'm typing the code, I'm getting that feedback right away. Versus on the other end of the spectrum, if I'm orchestrating an agent, I might tell it to go do something and not come back to it for hours. And so the trust required increases as you go up the ladder. The cost of failure goes up, and the time cost of failure goes up as you move up the ladder. And where we've seen most teams actually stall is they get maybe to one of those rungs, or they hit a problem at one of those rungs and never are able to get past it because they maybe try to jump rungs of the ladder and go straight from, we just use autocomplete to, we're going to use only agents and no one's going to look at an IDE anymore. And Gartner actually found that 40% or more of AI agent projects fail before they get to production, often because of governance gaps, right? If we don't conquer those lower rungs and they skip that trust building, then it gets a lot harder to trust something once you're giving over that autonomy. The example I give here is if anyone's been in San Francisco or the other cities with Waymos and driverless cars, that have no driver or driverless taxis, that's a huge trust that you're placing. And I remember I had a conversation years ago when I was in San Francisco and I hadn't been in one yet. And I was talking with a lot of folks in venture capital. Of course, they're very bullish on the technology, talking about how it's going to change the world and how it's going to, we're going to have driverless only lanes on highways soon, et cetera. And I really put the point to him. I was like, I knew he had a 6-year-old daughter at the time. I said, would you put your 6-year-old in a Waymo and send her off? And he thought for a second, a little deeper than the conversation before. And he said, yeah, I think I would. And that's what, convinced me to try and build that trust. So again, I think if you don't build up that kind of accumulated trust from those lower rungs, you're going to have a really hard time. And the way that trust fails, again, I think is these 3 kind of main failure modes. First is in context construction and giving the wrong context to the model, or not giving the right context to the model. So this is, the files that I select to give to the model to ask it to understand. It includes whether or not I'm using indexing and retrieval on the code base. Is there a relationship understanding there? And a lot of times what that looks like is we see, this kind of multi-turn things where there's high token counts or token counts that only build over time, and developers are, just adding on more context rather than kind of starting over with a fresh slate of context, and putting the right context in place right? We often see a failure mode where folks are trying to like walk the models back. But once it's kind of in that context, you have a lot of problems with the model ignoring it. Even if you're telling it, yeah, no, that was a problem. Don't look at that. It's still in the context at every new turn, and that can be a major issue. We also kind of track like how much manual like copying and pastings happen, and then users that kind of move between the rung 2 and rung 3, right? If they're not, if they aren't learning and figuring out how to construct the right context at that level, they're gonna fail in giving the agents more autonomy on their own. And the second failure point is in model routing. So this is like some data about how it looks to pick the best model. And the thing I talk about here is like, I remember before I started at Kilo Code back in March of last year. I remember thinking to myself, I don't want to learn about all these AI models. And that was when, there were maybe, I don't know, a third as many or less than there are today. And I think that's probably true of a lot of developers. And so I think most organizations are kind of coming at that like in two ways that can be both beneficial to their developers and hold them back, which is one, like standardizing on like some set of models or one model. And that can be good, right? Because it takes away that like kind of paradox or choice from the developer, but it can also be bad because as we've seen in, not only in benchmarks, but in this real world data that we're looking at here, how picking the right model for the right job is almost as critical as finding the best model, right? What best means, we've known in engineering for a long time that that's a subjective phrase, and it, what's the typical senior engineer's answer to what is best? Well, the typical answer is it depends, and that's true of models too. And so we've seen this kind of growing over time in kind of our most advanced users really spending a lot of time and using not only multiple models, but models from multiple different labs, right? Not being kind of pigeonholed into even one lab. And of those ones that were switching, 45% switched the models manually within the same hour, right? So that's, again, this idea of choosing the right model for the task, and making sure that we are not just kind of just throwing everything at the biggest model or the most expensive model we can, but really being thoughtful about how we use models. And not only that, it's interesting to me that when we look at just our enterprise users, it's actually a larger percentage that are using multi-labs than even just users overall, and an even crazier growth rate from the start of this year until now. And I think that's a reflection of that. We're seeing this kind of like price lock-in subscription model pricing from the large labs that have been subsidized for a long time. We've seen that go away over and over time, and that has opened up this world of possibly being able to not pigeonhole your users into one lab or one set of models, and giving them more model freedom. And I think that it's also interesting to then like look at two dimensions of data. Let's talk about the intensity of usage, like how users are. We've put them into 4 buckets here of light, regular, heavy, and power users. And then how does that translate into their multi-lab or multi-model usage? And you can see that it grows directly, right? And so it's those users that are using the most and getting the most out of a product, an agentic engineering tool like Kilo, that are actually using the most different models, right? We can see 92% are multi-lab models, and the average number is almost 8 different labs that they're using models from. And so when I say lab, I mean, of course, the big labs like an OpenAI or an Anthropic, the frontier labs, but also, of course, we give access to all of the open weight models from labs like Minimax and Quen and Kimi, and then obviously a lot of other models available. And so we see in those power users this curve of adoption where they're being a lot more particular about finding the right model for the right job. And the enterprise is actually following that same curve. So this then is a similar curve where we're seeing like what is the percentage of our enterprise org seats. So these are users that are like purchased Kilo Enterprise and are deploying Kilo across a large organization. What percentage of those quarter over quarter are using 2 or more labs models and not just pigeonholing themselves into one. And so I think this is a lot of like learned behavior that we're seeing over the past year, where developers are actually building that trust and working with the models and learning through real task completion. What does it look like to use the right model for the right task? And I think the design implication for both agentic tools, of course, like us, but also just for engineering leadership in general, is like any kind of routing that is done either automatically or maybe enforced via policy has to be task aware, rather than just assuming this kind of one model fits all world. And again, we don't think we see in the data that there's any consolidation really happening there, right? Because here we can kind of see that like the model market actually is diversifying over time. The top 10 models here by request volume, actually came from 6 different labs. And I think this is one day. I can't remember if this is like a period of a month. But we're actually seeing volume for the open weight models outstrip that of either Anthropic or OpenAI. And we're seeing, StepFun and XAI and Minimax. These models, attribute a large percentage of the usage over time. And this is all data that we also make public on kilo.ai/leaderboard. So you can actually see some of this data about which models are winning for a given which models are being used the most in a given day or a given week over time. And so then the question is like, how are developers actually switching? Like, are they focused on cost first? Are they focused on, finding the cheapest answer? Or are they focused on finding the best answer? And we found this kind of pretty divided world, right? Where some is like just balancing between, free models and paid models. A big set of them is really focused on only paid models and like which frontier model is the one that's worth it. And then we also have a lot of price sensitive early adopters, right? Like we have a lot of folks that are focused on like, hey, how can I get the best output for minimum to free input, by using our free models that are available either through the provider that's providing it for a period of time or our relationships with those providers. And so again, what does all of this kind of mean for the enterprise and for large businesses that are thinking about how to deploy? And I think this single lab dependency is a pretty significant risk, right? We've seen acquisitions in the market for some consolidation, but again, I think that relative market share is showing us that they're not necessarily seeing that as, oh, this is a true winner and one that I can get behind if I'm putting my, eggs in one basket as an engineering leader. But this kind of mature usage is actually spread across providers. It's not about any one lab losing. It's about, this kind of Cambrian explosion of models and labs that we've seen in the least in the year. And kind of maybe most importantly, if we think back to that rung of usage, right? It gets really important when you're talking about orchestrating tasks over a long time, that different subtasks of those tasks may need different models. And how can we make sure that we're not just, again, throwing away tokens or throwing away dollars on the most expensive models? And I think the way to think about that is how can we look at the feedback loop, right? Because that's the hardest failure point about like, did this work or not? Is how can I get this feedback and then learn, right? And that's again why I think it's important for folks not to just try to jump all in to, tomorrow I'm gonna stop coding and looking at the code completely, and I'm just gonna have agents do everything, right? Because that feedback loop is then very long and the cost of failure very high. So you really do have to build trust when feedback is quick, so that you have that trust once the feedback gets a lot slower. And that's why you don't want to don't want to try to jump too far without building this kind of muscle memory of feedback loops. And it's also, very asymmetric, right? Building trust, we know for developers, if we're engineering leaders trying to help developers build trust in these models, like it's very, asymmetric, right? Like, again, if we go back to a Waymo or a driverless car example, you've heard of every accident probably that a driverless car had. And of course, we don't want any accidents to happen on the road. But the reality is, if you look at the actual data, that, that's much safer and much less prone to accidents, per mile or however, or per capita in the cities they operate in. But it's very easy to destroy that trust and takes a lot longer to build it up. And so running, these tools at either the third or fourth rung of the ladder makes, you have to make the actions more visible. You have to make the feedback loops exist. You have to have structured progress that can build that trust. And so how do you measure that trust? Again, that's something that we've thought about a lot, because again, we're building these harnesses. And so we look at, rates of override for suggestions at the autocomplete level. For chats, we look at session depth and the follow-up rate, about like how many iterations does it take to get to a success. For agents, we look at the completion rate and like interruption rate there to see, it's like, are we able to trust the agent to do? And then for orchestration, it's really like, have developers really gone from agents to orchestration and used our orchestration tools for that. And so that's how we look at it. And again, I think something that engineering leaders should be serious about looking at in their own teams if they're trying to build this trust out over time. And then, again, I think the default rollout for a lot of folks is to kind of peanut butter across the organization by saying, here we go, we're going to give every developer access to, we're going to give everybody a cursor license or whatever it is. And there we go, like go forth and use AI now. And I think the problem is that optimizes for coverage, that optimizes maybe again for token usage, instead of building the trust by starting with developers who are, going to be okay with this ambiguity and help teams build in, whether it's the agents.md in their repositories or these other kind of tools that are going to help internally build trust, and then use their experience as social proof through the rest of adoption. And so the data tells us that we have to build for these things, right? That like context construction is infrastructure, right? We have to think about how are we building that? Are we choosing tools that are going to let us, really let developers really easily find the right context? I think provider independent routing is critical, no matter, again, the choice of tool. Independent of that, you also want to have independent provider routing, because the reality is that tomorrow a new best model is going to come out, and you're going to want your developers to be able to experiment with that and learn, is that the right choice? And then again, feedback loops that match the rung. We've talked about that in detail. And so if you're thinking about this over the weekend, and you're in engineering leadership, I think you want to go back to, the root of like, what models did your developers actually use last week? Are they able to route to all of the places that you've already got agreements with, or able to route outside of those if we were trying to build trust? And then are you measuring those trust signals? I think is really important. And so again, I think that it's not a capability problem. Adoption is really a trust problem, and building that trust and building that over time, I think, is the most important thing that folks are getting wrong in their AI adoption today. And again, benchmarks don't necessarily tell you what the best model is. It's like how your developers are actually choosing to do it really tells you a lot more about that. So again, I really appreciate the time taking your time today in looking at this. I'd really encourage you to check out kilo.ai/leaderboard. This gives you a lot more detail of some of the charts we looked at. And yeah, just really interested in how folks are seeing this. And again, we're trying to share as much data as possible so that folks can really learn what adoption is looking like in the real world.
Brendan, I had a quick question. So this data is coming specifically from users of your sort of coding assistant or does it
Correct.
come from anyone touching your your gateway?
So it's anyone touching our gateway, but I would say the vast majority of that is folks using our coding assistant, although you can use it in other ways. And then there are telemetry, specific telemetry things about the agent that's in use. So some of that, like if you look at, again, kilo.ai/leaderboard, it'll have like specifically the coding agent, the ask agent, like what was the agent used and how are people using models across that. And so it's like another dimension of looking at it. And so in those cases, then it's not only specifically our harness, but like the specific agent that you're choosing within the harness that can tell you a little bit more about that.
Yeah, it's interesting because like, so over the last 6 months, like since Claude Code kind of took over the, world or whatever, since like December, January time, where it's like we're focusing so much on these this paradigm of not necessarily just Claude Code, but these coding agent harnesses. So you have like a lot of developers, like that's how they're interacting with the AI, right?
Mm-hmm.
But their job is, it's like they're using it as a tool to get their job done. Then there's the other perspective of, kind of before 6 months ago, where a lot of people who are doing AI, they're doing something that's closer to like LangChain, like that style, which is it's a developer writing an agent interacting with the model. Like these are two completely different paradigms. And it's like of the data that you've kind of showed and is like, what do you think the kind of percentage is? Because I kind of struggled to reconcile those two models where they seem very different to me. Because if I'm writing, something closer to like LangChain, or if I'm doing like these DAG-based workflow type things, that's like, okay, I'm optimizing for repeated tasks. I care very much about the model, care very much about how many tokens are used per turn, context management. But then if I go towards the coding agents, you're a lot more hands off, like, because you don't, the style is just completely different. But
yeah, no, I agree. I mean, this is really focused more on that developing and using it as a tool in coding. But I think I would say that you're not wrong, but I think that is what's changing very quickly, because why is it different, Brendan, 6 months ago than now? Well, 6-8 months ago, all of the labs are subsidizing, trying to grab market share of those developers using it as a tool. And we're seeing like less and less of that subsidy happening over time, right? So like, for instance, Microsoft had Copilot, and they had this huge, you buy $20. I don't remember what the number was, but you buy a subscription and you get, a massive amount of inference. Well, they're moving, as of like September, everyone to API pricing, to usage-based pricing, right? And we're seeing that happen with a lot of the labs too, right? Where it's like, okay, Fable is in Claude Code for the next X number of days, but then after that, you're gonna have to pay for usage, right? And so I think we're seeing that, what we all kind of knew all along was like a very subsidized subscription where I can pay $20 and I get $200 of inference, or I can pay $200 and I can get $5,000 of inference. I think we're seeing that go away, and as you see that go away, now all of a sudden it matters, right? We've seen Uber, recently announced that they're like limiting the token spend for developers that are using it as a tool to write code. We're seeing a lot of folks like start to understand that like we can't just say, and not to pick on Opus. Opus is probably one of my favorite models, but you can't just say, oh, I'm going to throw every problem I have at Opus because it's going to be able to solve it. If that's going to cost 8, 10, 100 times what it would be to solve it with an open weight model, I'm not going to be able to justify that for long.
But so when you see because you talk about like model switching or model routing, like are you talking about if I'm doing a coding agent, that's the developer, doing /model and pick the right model, as opposed to there's also this other paradigm within like a gateway of like dynamic model routing, where it's like based on the complexity of the task, you determine what to do. So
so the vast majority of this data is the former, because we haven't until recently had much of the latter. So like we enable the developer to select whatever model they specifically want.
Yeah.
But we've also recently added, to your point, a number of like what we call them auto models, right? So it's like there's an auto free where it just uses whatever free capacity that we're able to get at, right? And so again, that's like a very cost sensitive thing. Or there's auto balanced where we have a certain set of models that we document. We're going to use these models for these agent modes. But then more recently, we've got an auto efficient model, which is doing exactly what you're saying, which is like based on actually our SWE bench data of our harness plus SWE bench plus every model out there for a given task. What's the right, what's the cheapest model that can get the task done? I think we'll see more and more of that as we're entering this like less subsidized world of tokens.
Yeah, because I really suspect that you're going to see something where the model providers like will start. I mean, I guess they're not completely incentivized right now to do it because why would they want to make less money? Mm-hmm. But it technically makes sense to push this into the model layer of like the model deciding how like this needs to be used more expensive versus cheaper tokens. It's kind of like the reasoning level. It's like you kind of decide, how many tokens are going to be dedicated towards this task, mm-hmm. where you could see where like, oh, if I put it to like, the super smart mode, it might be able to do some things in super smart and whatever, and some things in dumb or whatever. Mm-hmm. But I'm seeing that because like with Fable, yesterday I forgot I had switched this session to Fable because mm-hmm. I'm like, this is a really difficult task that I was curious to see if it would come up with a better design, and it did. I was happy with Fable, but when it got to implementation, I actually wanted to switch to like Opus or something like that. And I forgot. And because like, it was like at 5 o'clock or something, it's like, you're out of usage. And I'm like, I'm like, I've never ran it because I pay for the $200 one. I'm like, I never ran it. Like, oh, I forgot about Fable. So it was like, This is because, coming from a startup and we're VC funded, and I tend to just pick the most expensive thing. So I don't want to have to worry about it. So like, I typically don't care much about token usage, but even it's got to the point now where I'm like, crap. Token usage is something. So it's like, I am now actively going like, is this Sonnet, Opus, Fable? Like,
Yep. Exactly. Yeah, that's what I'm saying. I think we're going to see more of that. And I think you're right that like today, a given lab isn't necessarily incentivized to, like you said, like make less money. But I think as the competition among the labs heats up and the pressure comes from open weight labs where folks can even run it on their own hardware being a relative thing, right? Like a large organization could justify hardware for models. I think that pressure will necessarily cause the labs themselves to offer the ability to be more efficient, right?
Yeah, I just saw there's a comment that just came in. Sheng, I don't know how to pronounce his name, or Shannon. You see,
Abhishek.
Yeah, he was saying that the reality is that nobody has solved the ROI problem of inference costs. And I do think that is an underlying, because one of the things that bugs me is that it's like, oh, Uber is scaling back. Everyone's scaling back. But you know what? You wouldn't be scaling back if you were getting value out of it. And I think that's one of the big problems right now is everyone jumped on this AI thing of like, everyone do AI, and didn't realize like the cost skyrocketed with the assumption that we would get a lot of value out of this, and we're actually not getting enough value out of it. Like, I don't think it's like enough to say like, oh, this is a sham and stop. But like, we have to like pull back of like, look, wait. We're spending way too much. We're not getting enough back. We need to reevaluate, because this was not the magical bullet, like silver bullet that, in 6 months the world is going to be a whole different. It's like,
your Uber experience didn't get better. Like as a client, as an Uber client, it's not like, wow, now Uber is even more efficient. Like nothing changed. I've seen no improvement to Uber, despite obviously them spending, trillions of tokens. So
and the amazing thing is like, because engineers are always like, oh, this is crap, AI produces crap or whatever. But I think you can fairly objectively say, like, if you look at the products from the tech firms and stuff that came out over the last 6 months to a year, is like AI made things worse. And we're accepting that to a certain degree, but it's just a correction, like that's just the weird thing that's happening with AI is like everything is so accelerated that we just go 100 miles per hour in this direction and then hit a wall and go 100 miles in direction. So it's like we just like speed ran the getting to that trough of disillusionment or something, but like we're just gonna speed it's like it's absolutely nuts. Yeah, I don't know what the kind of the point is.
I think the truth is like the reality of the potential for dramatic change in how we build software, right? Like where does the AI sort of had the most impact, right? It's on people who don't code at all and suddenly can. Suddenly they're you talk to someone who's just like, oh my gosh, I built my first app, there you have this dramatic jump. Or you have it at the level of small teams, like very small teams who suddenly can produce new things in a time frame that was not, new features, new products, whatever they are. I think where it's sort of shown the least impact is in big, kind of well-established engineering organizations that pump out, our games, our big, web services, our enterprise applications. There, you already had a lot, you had a lot of capacity because there was a lot of money. So you already had rich capacity, and suddenly you added a lot more capacity potentially, but it didn't necessarily mean that you even had enough demand for new features in some of these areas where you're, again, it's like, what do I need from Uber that's dramatically different than I was getting from Uber? What do I need from my, fantasy football app that suddenly changed, right? Maybe they could do it with people. Maybe they're coming, they're able to bring some new ideas to market a little bit faster, but I think it's hard to see it. And we certainly haven't seen the tiny company break into big industry because they were able to build a competing stack very quickly that was better than or equal to existing software stacks, right? We haven't seen that change really in, now that we're 9 months in, right? There's no new insurance company that's offering insurance at half price because they're all AI written and AI delivered, experience. Nobody's undercut Geico that we've seen, right? It's not like, hey, come join a new insurance company that's going to cut your bill in half.
I think, like, because people always relate things to like the internet.com burst and things like that. It's like, I think we're kind of at this point where we're kind of experiencing the .com burst. It's not necessarily financial. Everyone talks about the financial that will crash, but this thing where like we all jumped in and expected something and then realized we weren't getting it. And it's like, that's kind of where we are a little bit now of like, we jumped in and we're like, it's going to be this amazing thing or whatever. And like, we're struggling to get that. But I think we're going to get right past this to like actually be like, no, this was the value. Like we thought it was all of this stuff, but it's really like this one thing. But it's very hard to say, because like you were saying, like, oh, you can have people who can't code can now code. And that's a very, as an engineer, I push back on that. That's a very nuanced thing. But I think when you look at AI, you have to kind of say, it's kind of like we've developed, it's like, how did the microprocessor, like the CPU, how did that impact, society? So many various different ways. AI is kind of the same thing where it's not like, so it's so nuanced in every single domain where it's possibly applicable. And there's not really like one size fits all solutions for all these things. Like it very much depends on every single application of AI of how it is, because it's like, I don't think the more and more I do AI assisted coding, I really don't think it's going to fundamentally change the game of engineering development. It's like, it's helping me overcome the complexity that we built over the last 20 years, but it's not suddenly like it's helping me survive and get back to the productivity that I used to have 15 years ago when things were easier, right? But now with this very complicated landscape, I'm accomplishing more. It's like I'm still kind of doing the same things, but my output is amplified to a certain degree. But it still requires a very technical person. But
don't you think that's a little underselling it there? I mean, I would argue I see features coming a lot faster than we were producing things 2 years ago.
No. Okay, but features are coming, but the problem is it's ramped up in the beginning. Well, if you look at the long tail, you get like, whoa, you can prototype so fast, but if you want to productionize whatever, you start hitting all the real issues, the things that engineers will always talk about. What do you spend all your time on? I don't spend all my time coding. I spend all my time doing other crap, right? And so AI has still not quite solved all the other crap, even though it will eventually make a lot of that easier. But so the thing is like, is the reality, because like you look and you say things like where it's like, like Claude Code, where it's like, oh yeah, this one engineer created Claude Code and vibe coded the thing and it's great. I suspect, I don't know, if you go into Anthropic, they probably have a lot of people working on Claude Code now, right? And it's not the velocity of that thing. It's faster, it's impressive, but it's kind of relative to the I don't know that it's fundamentally more impressive than startups I would have saw 10 years ago at their agility or whatever, when they were focused and really producing a product. So I think it's relative, because it's kind of the thing is like an engineer can, like, let's say 10x my productivity, but that becomes the expectation of everyone now, right? So it's like it's relative. So it's like I just think that you're right in that, like, I can kind of do more. I can definitely prototype way faster, but that's what I've been frustrated with, is when I look at the real thing of like all the crap of really doing production, really like what is the maintenance of this thing and stuff like that. It's like it gets hard. But there's a whole different perspective, like Shannon, that you gravitate towards, where it's like people who couldn't code can now code. And I say that's not really true, but I would command it. I would do it slightly different, of saying like people who could not like command computers can now command, right? Like if I wanted a website, I don't need a developer now to create a website, right? So that task, which is kind of like it's kind of like a well-known thing, I can automate away most of the thing, right? But develop like but if you're trying to, like, engineers, it's like the best value of engineering is like trying to create solve new problems, right? So that requires still like a very, like, if I'm trying to create a new type of thing by commanding computers, you still need to be a coder.
Yeah. But I mean, you can't outsource the thinking, right? Like Dex McCarthy says, like you can outsource a lot of the work to the agent, but you can't outsource the thinking.
Yeah, because it's
thing where I think I kind of push back there, and I mean, I would argue no, the value of these things are absolutely, the thinking is something that a lot of people who are not software developers are very good at and understand very much what they need software to do, but they can't write it, and they don't have people to write it, and they don't have the time to learn to write it, or that.
No, because they're still.
But now you have something else that can write the code and can show you not just a prototype, but can iterate that prototype to something that's production grade, and you can work through it like very much like a product manager. And I think you may be underestimating how far people are going to get with that, because it's going to keep getting better. And I'm already seeing by now my third, fourth, fifth thing that I've built, the learning of how to do that and how to sort of keep it on the rails as opposed to having it go off the rails, I think is materializing. And I think people are figuring this part out.
No. So for example, because basically your realm is like, you're like pretty much for the most part, you want like a website, an application, right? A web application, right? That's
you want an application. Yeah, exactly.
No, but specifically a web application, right? You're not trying
always. Sometimes I want a client. I mean, I want a desktop application, but whatever. Yes, an application.
Yeah, but whatever. So an application. What I'm saying is like your domain, right? So is like, that is a very well-known thing. But even if you want to create an application, if you have to first start from somewhere where it's like, okay, well, I'm going to use Firebase as my platform, right? So you already have those primitive, right? So you start from something. So there's a bunch of decisions already made for you. And so if you make all those decisions, you basically kind of put it together in a harness or whatever. So it's like, I'm going to use the Google solution, right? Then you're going to be fine because AI knows what to do. So like a bunch of decisions were already made for you. But like what's happening right now is there's this whole new realm of like agents is a new, like I've spent the last, whatever, like 20, 30 years or whatever in this web app DB world where it's like, that's all we do, web app DB, right? And then there's also queues, but it's like, for the most part, it's like, that's the architecture that kind of works. We now have agent and model, which are these two new architectural layers that we don't really know what to do with, but this is very clear that this is a new approach, a new thing. We're struggling to figure out what it is. I think we're getting much, much better at it. But you need engineers to do this. So as we go into this world of what agentic things look like, because I don't think mobile, desktop, web are going away, but there's something coming that's new, which is this agentic workload that we're going to need engineers to work on that problem. But when you look at that, it's like, I think the agentic workload is going to be 10x, 100x of whatever we're doing today. So, but I'm not going to get 10x, 100x of the engineers that I have today. I have the same finite number of engineers. They just need to produce 10x, 100x output or whatever. So it's kind of like the things that engineers care about, we're going to still need them to work on those things. But I don't need engineers to build websites so much anymore, right? So it's like those things, it's a well-known quantity. Like AI is very good at reproducing what we know. So it's like, that's a known quality. So
don't you think that will also then become, well known? Again, I think
eventually, right. But the cycle continues, right? Because like every time, like we are on this exponential thing. Like how, I don't know how, but like, because that's just the thing about AI is like, what I'm realizing is like, nothing to me seems fundamentally different than any other technology trend, except for the rate is so fast. Yeah. It's just so fast, but the technology is so powerful, so it compensates for it. It's like, oh, we still need smart humans. Like, yeah. My recent thing on X is I just keep hampering on the fact that it's like, we need engineers to go back to the fundamentals. Don't do the boot camp style where you just learn a framework and program React or whatever. We need smart engineers who understand the fundamentals of software, distributed systems, OS. You need to really understand what's going on under the hood, because all the tiny little details of pumping out code and stuff like that, AI can do that. But we still need people to understand that, because that's a critical skill or whatever. And I just think there's going to be enough anyways. So,
but we should wrap up a little bit. Just
this is ranting.
Last word for us today about where Kilo's going and what we should keep an eye on. Any big news coming?
Yeah, I think so today we announced a new evolution of the JetBrains plugin. So for enterprise users using JetBrains, it's like a massive upgrade for them. I had implied in my little talk, and then I saw that it actually happened, that a brand new model from OpenAI is out. OpenAI just announced 5.6 Sol and Terra, two different size models that I think are really exciting. And again, focus on one's a larger for heavy task, complex reasoning, and then Terra being more cost efficient. And then Luna even more fast and cost efficient. So we're seeing the labs again do this kind of like similar breakdown. And again, we had known that was coming. I didn't know if it was going to come out in time. Came out while we were talking. So I would just say stay tuned to the Kilo blog. We're spending a lot of time thinking about these things and how engineers need to think about it.
Awesome. Well, thanks so much for being with us today, Brendan. It was awesome having you. Darren, as always, thanks for joining and chatting. And we'll see you all next week. Take care.
Thanks.